Hi there, it's Jason Gorman from Codemanship with another video diary entry. Please like and subscribe if you're enjoying these videos and ring the bell for notifications of new content. Okay, so if you follow physics at all, maybe you studied it at school or maybe you're just a passing interest, you may well have heard of the famous thought experiment called Schrödinger's cat, devised by the quantum physicist Erwin Schrödinger. So this is an experiment in quantum mechanics designed to explore potential interpretations of what it all really means. In the experiment, a cat is placed, not a real cat, it's a thought experiment, remember, so don't do this at home. A cat is placed inside a sealed box with a phial of poison. And this phial can be activated, essentially shattered, by the random radioactive decay of an atom. So a single quantum event, if you like, a random quantum event. Now, the Copenhagen interpretation of quantum physics is that after a while, the cat in the box, before we can see it, is simultaneously alive and dead at the same time, which is a pretty weird thing to consider when you think about it. And that's the kind of the point of the experiment, is to explore whether we just don't know whether the cat's alive or dead, or whether it really is alive and dead at the same time, living in some kind of superposition. Now, the reason I'm discussing this particular thought experiment is I want to use it as a sort of a metaphor for code. So let's take a look at some code. Here's some code here. Now, we've got some code, and I've just run the test. Let's run them again just to be sure. And what running the test will do is like taking the lid off the box to reveal whether Schrödinger's cat is alive or dead. So we're sort of collapsing the wave function, if you like, of our code. It lives in a superposition of shippable and unshippable until we see it work. For example, if I were to change this code here, let's do a little rename refactoring. Let's rename it to foo, a popular nonsense word used in code examples. There we go. And now my code is in this superposition state. I've changed it and I haven't seen if that change actually works, whether I've broken anything. So I need to take the lid off the box to find out. I need to run my tests again, which is why continuous testing is so very important, because you don't want to live in that ambiguous state where you don't know whether it's shippable or unshippable, for example, whether it works or it doesn't work. So you take the lid off the box, you run the tests and find out. And all my tests are still passing. Now, the reason I'm showing you this in Rider is because there's a natty little function here where we run a coverage report. Let's just run our test with coverage. So we'll recalculate the code coverage that we've got, get that nice and up to date. And as you can see, apart from this separate web project, which I don't have any tests for yet, those tests are actually in a different project. We've got 100% unit test coverage and integration test coverage. So our coverage is high. Now, coverage tools are really useful for telling you which code is and which code isn't being executed by tests. But one thing that I always thought would be really useful is to have a sort of a reverse coverage tool. So you could select a line of code, like this line of code here, and find out which tests actually executed that line of code, which test would have to be rerun if we change that line of code. That's quite a useful thing, actually. Now, I think in JetBrains' little universe, I think it's only available as part of .cover. I've tried in IntelliJ and a couple of other tools, and I've not found anything along these lines. So it might just be a .NET thing, it might just be a .cover thing from JetBrains. But it's jolly useful because you'll see when let's redo that refactoring. In fact, we can just make a change to a line of code. So let's get rid of that floating space there. And you'll see I've got a continuous testing tool on, and at the moment it's identified that these tests need to be run. It calls them outdated tests. So these are the tests that would have to be rerun because of the change we made to the source code, which I think is a jolly useful thing to know. And it also really speeds up continuous testing because it's not always rerunning the whole test suite. It's just rerunning the tests that could have been broken by the change or the changes you just made, as well as new tests, of course. So that's the sort of very short point I wanted to make about I call it Schrödinger's code, if you like, when code sort of lives in this superposition state, this ambiguous state of simultaneously working and not working. In other words, we don't know whether it works. The only way to find out is to run it and test it and find out. And that's why it's important that your tests are fast, so you can do it over and over again. The rule for me certainly is that unless if I make any change to any source file at all, at that point I say that my code base is dirty. I'll put that in inverted commas. It's dirty code in the sense that it has not been retested. And my rule is that I do not commit code that hasn't been tested. So every time I change something, I have to rerun those tests that I would need to confirm to me that I haven't broken something, provided, of course, that they're good tests. But that's a different video, I think. So it's important to not veer too far from working code. So like Schrödinger's cat, the longer it stays in the box, the more of a superposition, the more ambiguous it becomes whether the cat is alive or dead, because there's more chances that it could have been killed, basically. And it's the same with code. The longer it goes untested, the more likely it is that it is broken, basically, because you're making more and more changes and not retesting. So I encourage developers not to stray too far from working code. And I have very strict policies when I'm leading teams, for example. It's an absolute no-no, certainly to push code that you haven't tested. I would strongly recommend not committing code unless you've seen it pass the tests. Again, provided they're good tests. And you certainly wouldn't deploy it unless you knew that it was working, unless you had high confidence in it. So that's Schrödinger's code. Once we've edited code, it goes into this sort of weird, ambiguous superposition state, a probability distribution of both working and not working. And the longer we go before we retest it, the more likely it is that it's not working. The more likely it is that the cat is dead, basically, when we lift off the lid, which is not a pleasant experience for anyone. So, Schrödinger's code, you've got to get back. Got to collapse that wave function as soon as possible, get back to working code or get back to seeing the code work before you make more changes. And remember that discipline. Do not commit code without testing it first. Certainly don't push it without making sure it's passed all of its tests. And certainly don't deploy it unless it's passed all of its tests in a build environment, for example, on a CI server. So there you go, Schrödinger's code. That was my little video diary for today. I hope you're well and staying safe. Until the next one, take care.